Now, whenever again the same thing, whenever P is being positive, P positive இருந்தா focal length அப்போ positive இருந்திருக்கும். யாருக்கு focal length positive? For your converging lens. So here it will be considered as a convex lens. And similarly, when P is being negative value, then it is a concave lens. This one. Convex lens is being made up of a glass of refractive index 1.5. If the radius of curvature of each of its two surfaces is 20 centimeter, find the ratio of power of the lens when placed in air to its power when immersed inside a liquid of refractive index 1.25. So airல இருக்கும்போது எவ்வளோ, liquidல இருக்கும்போது எவ்வளோ, அதோட ratio they are asking. P1 by P2.
Five by two, sir.
5 by 2 is the correct answer, sir. So power of 1 will be equal to mu2 by mu1. So it will be of your 1.5 minus 1 and 1 by r1 minus 1 by r2. இங்க நீ வந்து calculate பண்ண தேவையில்லை, ஏன்னா ரேஷியோ தான் கேட்கறான். எப்படியும் 1 by r1 and that will be getting cancelled. Now similarly for P2. Now immerse பண்ணும்போது who is the second liquid, second medium? The same liquid, glass, right? So 1.5 divided by first medium is 1.25 minus 1, and this will be 1 by r1 minus 1 by r2. Ratio எடுக்கும்போது you will get cancelled. So P1 by P2 will be equal to 5 by. புரிஞ்சுதா? அங்க போய் ரேடியஸை சப்ஸ்டிட் பண்ணிட்டு இருக்காரு, ஏன்னா ரேஷியோ தான் கேட்கறாங்க. ஸோ டோன்ட் வேஸ்ட் யோர் டைம். Next one is about the rules of image formation in the lenses. The ray passing through optical center goes undeviated. The ray passing through F1 after the refraction becomes parallel to PA, which is nothing but your principal axis. And இதோட அப்படியே opposite. When a ray passing parallel to principal axis after refraction, they'll be meeting at the focus. Parallel to principal axis after refraction, it will meet or appears to meet at the focus. So these are the basic rules for the image formation in the lenses, right? Now comes your image formation of convex. So அங்க எப்படி concave mirror இங்க வந்து convex lens it has got the 6 different mirror formations. I mean the image formations. This is a convex lens, principal axis which is passing through the optical center. So let it be 2 times the focus f1. Sorry. Yeah, f1, and this is your f1 value, right? And this is f2, 2 times of. When it is placed at infinity, எங்க வந்து ஆப்ஜெக்ட் வந்து ஆப்ஜெக்ட் இன்ஃபினிட்ல வச்சனா where it will be formed at focus. Next is beyond 2f1, second position. Beyond 2f1 no, sorry, between f2 and 2f2, so second position. Third position is at the center of curvature, then it will be of your at 2f. Next between 2 and f2, so it will be beyond 2f2. Now last one is about focus la na place பண்ணனா image will be formed at the infinity. So this is your infinity sign, right? So left side la irukka full image oda positions and right la sorry object oda positions and right la full image oda position. So these are the positions of image and position of the object, right? So now next comes its nature. 1 la irundhu 5 வர. What about its nature? Forget about the size, only nature. Real and inverted. So 1 la irundhu 5 வர, the nature of the image is real and inward. Am I right? Next comes your the sixth position. Sixth position enga sir? Between optical center and the focus. When you are placing it in this side, so parallel meeting the second focus, and the other one will be like this. Correct? When it is being extended, it appears to meet somewhere on the same side of the object. So this is your image and this is your object, right? அப்ப இந்த இடத்துல what happens? This is the sixth position. So nature of images virtual and direct, right? இப்ப ரொம்ப இம்பார்ட்டன்ட் என்னன்னா அதோட மேக்னிஃபிகேஷன் தான். when you are just moving it towards the mirror at infinity means the image is formed at the focus, but the size is diminished, point size, right? Next, when you are placing it to, still it will be diminished only. At c means same size. At between 2 and f na enlarged, and this will be of your highly enlarged. But what about here? It will be highly enlarged only whenever you are placing it between, but the nature around it changes. It will be virtual and direct. So this is the image formation by only the convex lenses. concave lens. இங்க ரெண்டே ரெண்டு இமேஜ் தான். Optical center 2 times f2 and this is f2. f1 2 times 1. Right, sir? So the first one is about when it is being placed between optical center and the focus. Then, infinity to the optical center. இதுக்கு நடுவுல எங்க வச்சாலுமே, let me take, so first one is between infinity and optical center. Right. So I'm just placing it here, somewhere here. This convex என்ன ஆகும்? Diverge ஆகும். So it will be diverging something like this, right? And one more ray which is passing through the optical center. அப்ப இந்த டைவர்ஜென்ட் ரேவை நான் இப்படியே கொண்டு வந்தேன்னா என்ன ஆகும்? ஹியர் ஒரு சின்ன இமேஜ் வந்து ஃபார்ம் ஆகும், கரெக்டா? பட் ஸ்டில் த நேச்சர் இஸ் பீன் size is been diminished only, right? So image is being formed between optical center and the f2 value. Its nature is virtual and erect, and the size is diminished. Not point size, it will be somewhat diminished. Next one is about actually the first one. So when the object is coming from the infinity, so infinity ல இருந்து light வந்து rays travel ஆகும்போது they will tries to diverge, and when I extrapolate this line, they will be meeting at the f2 value. Correct? So image is at f2. Nature என்ன சார்? சேம் சைட்ல தானே ஃபார்ம் ஆகுது. So it will be same, virtual and correct. And what about its size? Point size or highly diminished. So is there any possibility that concave lens forms a magnified image? No. Always it will be forming a diminished image. Magnify image ஆனா virtual and direct இருக்கணும்னா எந்த லென்ஸால முடியும்? Convex lens. Right. The combination of thin lenses. So this is a lens So ரெண்டு thin lens, I'm just keeping it together. I mean, in contact with each other. And this lens has got the focal length f1, and this has got the focal length f2. And this is your principal axis that is passing through its both the optical centers. Right, sir? Now, அதே மாதிரி தான் object light is being passing through this. என்ன ஆகும்? This will be exactly formed at the somewhere here. Correct? Due to the first one. Now, no, sorry. A1, okay. So this is the image formed by the first lens. Now, in the image will be acting as a virtual object for the second lens, and ultimately the image will be tries to fall somewhere here, which is of your final image I. Okay, now இவங்க ரெண்டு பேரும் combine பண்ணி தானே we are just going to take a combination of one lenses. Now the image distance will be u from its center. அதே மாதிரி object distance. Image distance formed by the first refractive index, அதை நம்ம என்ன எடுப்போம்? V dash. Final images V from the center of the combinations. Right, sir. Now, what about the first lens formula? Due to first lens, என்ன ஆகும்? What is the formula? 1 by f1 will be equal to 1 by v dash minus 1 by u. Correct இல்லையா? Similarly, due to second lens, 1 by f2 will be equal to, now இந்த இதுதான் உனக்கு ஆப்ஜெக்ட் ஆக்ட் ஆகும், ஆப்ஜெக்ட் டிஸ்டன்ஸா. ஃபைனல் டிஸ்டன்ஸ் இஸ் வாட்? v minus 1 by v dash. Now add both of them. What you will get? 1 by v dash, 1 by v dash cut ஆயிடுமா? So you will get this 1 by f1 plus 1 by f2 will be equal to 1 by v minus 1 by u. In the 1 by v minus u na, it is the total focal length for the complete system. ரெண்டு லென்ஸுமே சேர்த்து எனக்கு வர்ற equivalent focal length is what? 1 minus v by 1 by v minus 1 by u. So I can write this as 1 by f1 plus 1 by f2 will be always your 1 by f equivalent. இந்த மாதிரி மூணு லென்ஸ் வச்சேன்னா plus 1 by 3. நாலாவது லென்ஸ் வச்சேன்னா plus 1 by 4. It will be keep on going. Correct? Now what is the power of combination of this power? This lens 1 by f1 is power p. So it will be p1 plus p2 will be your power equivalent also. And ரொம்ப இம்பார்ட்டன்ட், இது ரெண்டும் லென்ஸா நம்ம கன்வெர்ட் பண்ணோம். கரெக்டா? ஃபார் the mirror combination, when two thin lenses are being making a contact, we can just write it as 1 by f1 plus 1 by f2. Now when it is about the mirror, அதோட power will be inverse of this, I mean negative of your the expression. So the power for the mirrors will be equal to minus 1 by f. அதே lens இது இருக்காது, it is being of quite different in nature. This is for the power of the mirror, that is minus 1 by f is the case. புரிஞ்சுதா? இதை வச்சுதான் next comes your what is it? Silvered lenses. Silver lenses NCRT la kadayadu. But for state board, it has been there. Right? For JE also, it has been there. Silver lens means the same lens, whatever the lens you are having, one curved surface is being covered with the polished surface. So என்ன ஆகும்னா ஒரு எட்ஜ் ஆஃப்ல இதுல ஒரு ஸ்பெரிக்கல் சர்ஃபேஸ்ல ரிஃப்ராக்ஷனும் இன்னொரு சர்ஃபேஸ்ல ரிஃப்ளெக்ஷன் டேக்ஸ் பிளேஸ். ரைட்? So next comes your silvered lens. Let me take a convex lens. And convex lens, one side of the spherical surface is being covered with the silvering. That is mean polished surface. This is your principal axis passing through its lens. Right? இங்க வைக்கிற ஆப்ஜெக்ட் என்ன ஆகும்னா, ஃபர்ஸ்ட் திங் இட் ஹிட் ஹியர், ரிஃப்ராக்ஷன் நடக்கும். ரிஃப்ராக்ஷன் நடந்து இங்க போய் என்ன ஆகும், ரிஃப்ளெக்ஷன் நடந்து again it will be falling somewhere here. So this is where how the image and the object, image is being formed due to some object. Now இததான் நம்ம மூணா பிரிக்க போறோம். யார் யாருன்னா, ஃபர்ஸ்ட் சர்ஃபேஸ்ல ரிஃப்ராக்ஷன், செகண்ட் சர்ஃபேஸ்ல ரிஃப்ளெக்ஷன், திரும்ப வெளியே வரும்போது ரிஃப்ராக்ஷன். Now it is a combination of what and what? Mirror and the lens. So here 1 by focal length, that is the total focal length, equivalent for F equivalent will be equal to, okay, நான் பவர் வச்சு வரேன். Power equivalent will be equal to, what are the lens? First thing is about the lens, PL plus, second it வந்து power of the mirror plus திரும்ப வெளியே வரும்போது power of the lens. Am I right? And we know that 1 by F equivalent will be equal to 1 by V plus 1 by U. இது வந்து யாரோடது? F equivalent. ஏன் சார் இங்க பிளஸ் போட்டேன்? Overall it is going to act as a mirror. F equivalent is been off. V minus U னா லென்ஸுக்கு தானே வரும் அது. என்னடா? அது வரேன். சரி, வெயிட் பண்ணு. Okay. Now, next comes the power of lenses. So the overall power equivalent is going to be what, sir? 1 by F equivalent. It is overall one of it as going to act as a mirror. Will be equal to power of lens என்ன sir? 1 by focal length of the lens minus 1 by focal length of the mirror திரும்ப plus 1 by focal length of the lens. Right, sir? So ஆக மொத்தம் this is because only that negative sign is being because only due to the mirror. என்ன mirror? Concave mirror, which is going to be acting as the power equivalent. Right. Okay. So ஆக மொத்தம் this is your general equation. So minus 1 by Fe will be equal to 2 by Fl minus 1 by F. இல்லனா negative sign போட்டு you can just write it as this. என்ன சார்? மொத்தமா இது கான்கேவ் மிரர்ல தான் ஆக்ட் ஆகுது. ஸோ ரிஃப்ளெக்ட் ஆயிட்டு திரும்ப இதே சைடு தானே வந்து ஃபார்ம் ஆகுது. ஆன் தி அதர் சைடு ஃபார்ம் ஆகலையே. ரைட்?
சார்
எஸ் சார்.
சார் -1/FE சார் எழுதணும்
ஃபார் மிரர் சார். மொத்தமா இந்த overall the equivalent is being going to act as refraction, reflection, திரும்ப refraction. இது எல்லாமே மொத்தமா சேர்த்து இமேஜ் எந்த சைடு வந்துச்சோ அதே சைடு தான் ஆப்ஜெக்ட் வந்து ஃபார்ம் ஆகுது. ஸோ அல்டிமேட்டா உனக்கு இது மூணும் சேர்த்து இட் இஸ் கோயிங் டு ஆக்ட் அஸ் வாட் மிரர் ஒன். தட்ஸ் வை. ஸோ மிரரோட பவர் என்னது? திஸ் இஸ் ஈக்குவலன்ட். ஸோ பவர் ஈக்குவலன்ட் விச் இஸ் நத்திங் பட் இப்பதானே படிச்சோம் -1/FE.
எஸ் சார்.
தட்ஸ் வை. அப்ப இந்த -1/FE எப்படி எழுதலாம்? So 1/FE will be always equal to 1/V plus 1/U. Right. Now comes your focal length. 1/S L எப்படி எழுதுவோம்? Focal length of the lens. வெளியே ஒரு மீடியம், உள்ள ஒரு மீடியம். How will you find it? What is the lens maker formula? Exactly. N2 by N1 minus 1 into 1/R1 minus 1/R2. புரிஞ்சுதா? Any doubts here, sir? Yes, sir.
So we can do the same for concave also, sir.
Yes, sir. It has been combination of, like, even if you're considering for the concave, இது எல்லாமே it's of only assumption is that we are making it as a convex, point object. All these angles are being small, so it has been applicable for both concave as well as the concave.
Sir, ஆனா அதுல கான்கேவா இருந்துச்சுன்னா f நெகட்டிவ் ஆகாதுல சார்? 1/FEங்கிறது நம்ம மைனஸ் சப்ஸ்டிட்யூட் பண்ண கூடாதுல?
பட் அல்டிமேட்டா உனக்கு மிரரா தானே வந்து ஃபார்ம் ஆக போகுது. here you will be using this about the, where is it, first surface வந்து உனக்கு லென்ஸா ஆக்ட் ஆகும். கரெக்ட்டா சார்?
எஸ் சார்.
So this is the surface, this will be acting as a lens. So this is your 1/FL value. So focal length will be negative. Correct? Now
Yes, sir.
this will be acting as a convex mirror.
Okay, sir.
So convex mirror க்கு நான் வந்து பாசிட்டிவ் 1/FM க்கு பதிலா m வந்து பாசிட்டிவா நான் எடுத்தேன்.
ஓகே சார்.
என்ன சார்? ஒரு எங்க இல்ல, இத நான் இப்ப தனியா எடுத்துட்டேன்னா இது எப்படி இருக்கும்னா இட்ஸ் a combination of லென்ஸ் அப்புறம் ஒரு மிரர், இதை சேர்த்து வைக்கிறதுனால. அதனால இப்ப இதுக்கு R1 இதுக்கு R2 தானே வரும். இது ஈக்வி கான்வெக்ஸ்னா R1 R2 ரெண்டு சேம்னு போட்டுருவேன். அதனாலதான் இட்ஸ் a combination of two. So this is the combination. இது plus convex lens and a concave mirror. Next comes the other part of this chapter, which is of prism. So we have just, this is also same under the concept of a refraction only, right? The only thing is that refraction na இதுக்கு வர பார்த்ததுல வந்து ஆப்போசிட் சைடுல வந்து it will be refracting, right? இது வந்து prism குள்ளேயே வந்து prism has got n number of, sides we can make it 3 prism, 3 faces வச்சு இருக்கு, 4 faces வச்சு I can just make it a prism. The thing refraction goes is that adjacent faces la தான் உனக்கு இந்த இடத்துல refraction நடந்துருக்கு, not exactly at the opposite, right? Adjacent refract ஆகுது, and due to that refraction what happened? So you would have studied it in the earlier classes that in 10th standard, when a white light has been passing through the prism, it will be splitted into 7 of its component colors, and which we call it as the which are the colors. This process phenomenon is called as the dispersion of light, white light. one color is being dispersed into 7 colors. That is, white light is being dispersed into the 7 colors. Right. Now, in this case, let this be the prism. And A denotes the angle of prism. Right. So, அதுக்கு முன்னாடி it's types actually. So, the prism nala how we can able to see it. So, one of the principle of using the prism is that your total internal reflection takes place. Binocularly, we are using the prism like a cylinder, what is it? Triangular prism, right angle prism. So, based upon this we would have been studied it in the examples of your applications of your TIR. Total internal reflection. So, the first one is about if you are having a right angle prism. So, in here, hit, if it hits. So, here is an object. So, after this, it goes like this. And the total internal reflection, it will be something like this. Right? So, this is being based upon your right angled prism. Right? Now, next comes the same right angle prism. It has got some property. So, the object is being tilted by what angle? Image 90 degree, right? 180 degree turn பண்றது இருக்கும் with the same of your same right angle prism. So, something like this. How to see? Yes, 90 degree. So, what happens here is that இங்க இருந்து வந்து ஹிட் ஆகி இங்க இடிச்சு இங்க இடிச்சு again it goes like this. So, இப்படி இருந்த image இப்படியா the same right angle prism. Right? Okay. And this is all due to the properties of what? Your total internal reflection. Now, let me talk about this prism here. First one is this. And in the surface, this is the normal. And this angle is what we call it as angle of incidence. So, in the line of the PQ, in the ray of the PQ. Now, after the refraction, it will be bending towards the normal. So, it will be going like this. And never ever draw the ray parallel to your base. Parallel to the base எப்போ வரும்னா when it has got the minimum deviation. புக்ல அப்படிதான் இருக்கும், parallel வரைஞ்சிருப்பாங்க, ரைட்? அந்த parallel வரைஞ்சது எதுக்குன்னா minimum deviation இருக்கும் போது தான் this refracted ray inside the prism will be parallel. ஓகேவா? But in general you are just drawing it as a making some not exactly parallel to the base of the prism. Right? Now இப்போ இங்க போய் ஹிட் ஆகுது. Now இங்க ஹிட் ஆச்சுன்னா this will be the normal here. Now, denser to rarer podu, so it will be moving away from the mirror. Sorry, away from the normal. PQ in the point R and in the point S and this angle is your emergent ray. And ulla inge hit another your angle of R1 and this is R2. Now, next comes the deviation. Deviation என்னன்னு சொல்லி பார்த்தோம். Angle between your incident ray and your emergent ray. அப்ப incident ray இதான் உன்னோட incident ray. இது இப்படி போயிருக்க வேண்டியது. கரெக்டா? எமர்ஜென்ட் ரேவையும் அதே மாதிரி எக்ஸ்ட்ராபோலேட் பண்ணு. Now, the angle between this is what we call as the del value, which is of angle of deviation. So write down here, A is the angle of prism, R1, R2 is your refracted angle, E is your emergent angle, del is your or angle of deviation. Yes sir, R2 வந்து incident for second surface தானே. ஓவராலா பார்க்கும்போது இங்க ஒரு ரிஃப்ராக்ஷன், செகண்ட் சர்ஃபேஸ்ல அங்க ஒரு ரிஃப்ராக்ஷன். இன்சிடென்ட் வச்சு பார்க்கும்போது சாரி ஃபர்ஸ்ட் இந்த ரே வச்சு பார்க்கும்போது அப்பதானே இது இங்க இருந்து வெளியே வருது. ஸோ ஃபர்ஸ்ட் சர்ஃபேஸ்ல ஒரு ரிஃப்ராக்ஷன், செகண்ட் சர்ஃபேஸ்ல ஒரு ரிஃப்ராக்ஷன். அதனால தான் R1 R2ன்னு இருக்கு. ரைட், நீ வெறும் நீ எப்ப சொல்றீங்கன்னா ஒன்லி இஃப் ஐ ஜஸ்ட் கன்சிடர், ஸோ லெட் திஸ் பி பாயிண்ட் பி, ஸ்மால் a b c. ஃபர்ஸ்ட் ரிஃப்ராக்டிங் சர்ஃபேஸ் இஸ் ab, செகண்ட் ரிஃப்ராக்டிங் சர்ஃபேஸ் இஸ் ac. கரெக்டா? ஏசிக்கு மட்டும் நீ கன்சிடர் பண்ணீங்கன்னா அப்பதான் R2 is acting as a incidence angle for that surface. வேற ஆங்கிள் போகுது, அதான எமர்ஜென்ட் நமக்கு. Here comes the angle of deviation. Right side. So angle of deviation வந்து, as I said, the angle between the emergent ray and your incident ray. Right. So this is the angle which is going to be of. இந்த ஆங்கிளோட வேல்யூ எவ்வளவு சார் இன் டர்ம்ஸ் ஆஃப் இன்சிடென்ஸ்? இது ஐ, இந்த மொத்த ஆங்கிளும் ஐ. அப்ப இந்த ஆங்கிள் மட்டும் எவ்வளவு? ஐ மைனஸ் R1. Similarly, this angle is E minus R2. Interior angle will be equal to your sum of interior angle is your exterior angle. So I can write this as angle of deviation is equal to I minus R1 plus E minus R2. கரெக்டா? இதை நான் எப்படி எழுதலாம்? Deviation is equal to I plus I plus E minus of R1 plus R2. This is going to be your angle of deviation. Right up? Up. Condition of no emergence. அதாவது பிசில இருந்து எமர்ஜென்ட்டே ஆகக்கூடாது. இட் ஷுட் பி கிரேசிங் த்ரூ த சர்ஃபேசஸ். கிரேசிங்னா என்ன அர்த்தம்? அலாங் த ஏசி த எமர்ஜென்ட் ரே ஹேஸ் டு பி ஃபாலோ. இப்படியே அலாங் திஸ் தனியா தெரியக்கூடாது. ஸோ வாட் வில் பி த கண்டிஷன் ஃபார் தட்? Angle of R2 will be equal to your emergent will be equal to your 90 degree. Am I right? So here the case is that if your A, that is your angle of prism, is being greater than twice of your theta C. Theta C is nothing but your IC value. IC na enna solli paathom? Critical angle, exactly. So this is going to be your critical angle. Then your mu will be greater than 1 divided by sine A by 2. This is the expression which they have given it for this condition. Such that இது ஒன்னோட triangle, prism, and this is your angle of prism. This is your angle of incidence. And refract ஆகனதுக்கு அப்புறம் it travels like this. So this angle is R1. This angle will be R2. Right? So this will be the condition for the angle, the emergent ray to not emerge from the second surface, refracting surface. It should be grazing through the surface. Okay. The condition for, as I said, the grazing emergence. Oh, sorry. Once again. No emergence now. Oh, sorry, sir. Once again. போயிட்டு hit ஆயிட்டு திரும்ப internal angle சுத்திட்டே பாருங்க. Yeah. So it will be reflecting into the prism again. Kindly make this reflecting into the prism. Into the prism எப்போ வரும்? Whenever your incident angle is greater than your theta c value. Correct? And இங்க incident யார் இந்த second surface? R2. Right? Sorry. It's not grazing. Second case தான் grazing. The ray reflects back to the prism here. இப்போ now comes your grazing case. Same angle of prism, the angle of incidence, அதோட normal, sorry, I1 incidence, refraction, and comes your grazing. So இந்த இடத்துல தான் your angle of emergence is equal to 90 degree. And this is your R1 and second refraction is R2. Right. So here E will be equal to 90 degree and your R2 should be equal to another greater than or equal to your critical angle, equal to your critical angle theta c. Set up. Next comes your angle of prism. That is, A will be equal to your R1 plus R2 value always. இதை நம்ம ப்ரூவ் பண்ணுவோம் இந்த மினிமம் டிவியேஷன் அதுக்கு முன்னாடி வரும்போது how to find the refractive index வரும்போது how this A has become R1 plus R2 value. Now what about the deviation? Deviation இதுக்கு முன்னாடி என்ன பார்த்தோம்? I plus E minus of R1 plus R2. So I can also write it as your del value as I plus E minus your angle of prism. இப்ப சொல்லுங்க சார். Therefore, A will be equal to R1 plus R2 தான் நமக்கு என்னது? Your critical angle theta C. Right? Now, what about its critical angle? We also know it. Sin theta C will be equal to 1 by mu. Correct தானே? Now your sin I, that is by Snell's law. So it has been moving on with the respective வெளியே the RR medium, and inside this is going to be your refractive index of, let it be n. So I can write it as 1 into sin I will be equal to n into sin of R1 case. Correct இல்லையா? First refraction across A, B, C. So this is for small a, B surface. Correct, sir? Now, therefore, sin I will be equal to n into sin R1 எப்படி எழுதலாம்? In terms of a refractive index, critical angle. R1 is equal to A minus theta C value. So I can write it as A minus theta C, and sin A minus B. I can write it as sin A minus B is sin A cos B minus cos A sin B is the case. By substituting all this together, you will get sin I will be equal to under root of your refractive index square minus 1 into sin A minus of cos sin cos. Okay, sir. Oh, man, mu வச்சிருக்கேன். Okay, then change it to mu. So this will be your angle of incidence spin. Sin I. வெறும் I மட்டும் கேட்டாங்கன்னா sin inverse of your under root of this one. Right? இப்போ எங்க C எங்க போச்சு? theta C. So 1 by mu is your theta C value. So அதே இது cos C ன்னு வரும்போது I'll be taking cos theta C also I can make it. ஏன்னா sin 1 by mu எனக்கு எவ்வளவு தெரியும்? Cos mu is nothing but adjacent by your hypotenuse, which is under root of mu square minus 1 will be the case. Right? So this is the angle for your another angle of incidence for what condition? Grazing condition. Emergent ஆகுது, but it is being grazing through the surface. So 3 cases have been there. இது ரெண்டும். After the third case is when it is having a maximum deviation. So write this down. Condition for your maximum deviation. So in order to have a maximum deviation, your angle of incidence should be 90 degree. That is, if this is the prism, angle of prism, then இந்த இதுக்கு இதான் நார்மல் சர்ஃபேஸ்னா எனக்கு லைட் ஹேஸ் டு பி கமிங் சம்திங் லைக் திஸ் ஸோ தட் தி ஆங்கிள் ஆஃப் இன்சிடென்ஸ் பிகம் 90 degree, right? So after that it will be refracted somewhere like this. And where is it? Deviation. Okay. And in the இதுக்கு this will be the normal and this will be your emergence. ரைட்டா சார்? இப்போ டெல் வேல்யூ எங்க போகும்? அப்படியே எக்ஸ்ட்ராபுலேட் பண்ணினா this will be your del value. Okay, now del maximum should be equal to what is the equation we have seen? I plus E minus A. I எவ்வளோ? 90 plus E minus A will be the case. So this will be the condition for your del maximum. And where your sign of emergence? Sin I by sin R will be equal to I minus E value. So with respect to your critical angle, sin inverse E mu sin A minus theta C. So this will be a sign of emergence. Condition another for maximum deviation. இதுக்கு அடுத்து வர்றதா நீ ஸ்கூல்ல படிப்ப. What deviation? Minimum deviation. Mu to same Snell's law you will be applying it, right? So what is the minimum deviation case here? How do you just derive this? Prism வரைஞ்சிட்டு PQRS yes sir. ஆமா சார். A90 I90 சொல்றீங்க. அது ரைட் ஆங்கிள் பிரிசமா இருக்கும் போது தானே இது என்ன வேணாலும் இருக்கலாம். ஸோ அதனால ஜென்ரல் கேசஸ் if it is 90 for 90 then director நீ substitute and it is 90. Next comes your condition for your minimum deviation. Right. Angle of A, your normals, angle of incidence parallel to this since it's all got the minimum deviation, R1, R2, angle of emergence. Right, sir? Now, what about this angle? I minus R1 and this angle will be E minus R. Next எப்படி போவோம் and if you extrapolate this line this will be your del value, right? So del value we already know how much is this? I plus E minus A, where A is equal to R1 plus R2 is the case. Correct, sir? Now, for the D minimum. So for the D minimum, two cases. First thing is about R1 should be equal to R2. The angle of refraction should be same. Right? Now, இப்போ இது வெளியே வந்து let me take it as R, and inside it has got some medium. Use the case. Correct, sir? How do you write this? Mu2 by mu1 will be equal to sin R by sin I by sin R. And one more condition. What is that? For minimum deviation, angle of incidence should be equal to your angle of emergence. இந்த ரெண்டு கேஸ் இருந்தா மட்டும்தான் ஈக்குவலா இருந்தா மட்டும்தான் then the light will be undergoing a minimum deviation. Now here comes your del value. So this is by Snell's law. You keep this as it is. Right up. Now del minimum will be equal to I plus E के बदला I minus R1 plus R2. So ரெண்டுமே equal to சொல்லும் போது shall I take it as equal to some R value? So it will become how much, sir? 2R. Correct? And also again A will be equal to, so R will be equal to A by 2 is the case. Correct? Now from here, 2 times I will be equal to del minimum minus, plus 2R, and I will be equal to divided by 2. Am I right, sir? Now, in the 2R is nothing but your angle of prism. So ultimately, your I will be equal to D minimum plus A divided by 2. Let this be the first equation. Now, R oda value எவ்வளவுன்னு சொல்லி கண்டுபிடிச்சோம்? A by 2. It is second equation. Apply this in the your Snell's law. So what you will get it is mu will be equal to mu2 by mu1. R will be equal to sine of I. I oda value எவ்வளவு sir? D minimum plus A divided by 2 divided by sine R value. R value is A by 2. So with this, for minimum deviation, we can able to find out the refractive index of the prism. Right?
சார்
Right. Yes, sir.
சார் கொஞ்சம் மேலே ஸ்க்ரோல் பண்றீங்க
Yes, sir. இதுவாரா?
ஓகே சார் தேங்க்யூ.
Next value has been of your D minimum. So the graph of this, so it is common now. So how will you get the graph for your D minimum. So the angle is between, the graph is between your deviation with respect to your angle of incidence. So the graph goes like this. Not an exact parabola, but it will be something like a parabola. So the minimum point, so this is going to be your D del minimum, where del minimum la your I will be equal to your angle of emergence. Yes, sir. Yes, sir. And this will be your D maximum. So except the D minimum, D maximum, del deviation ki endha angle eduthalume there will be two incidence angles. So one is of I1 and the other one is of, so let this be of I1 and I2. Maximum ஆவே இருந்தாலும் I1 I2 தான் இருக்கும். So minimum க்கு மட்டும் தான், except the minimum, all has got the two possibilities for the angle of incidence in order to have a maximum deviation. So only for one angle, the deviation will be minimum. For your thin prisms, so thin prisms in the angle of A is being much more smaller, then what happens is this. So by according to the Snell's law, so let this be the thinner prism. So this is of angle of incidence A, and same adhe marna. Your I1 is the case, refracting R1, R2, emergent, and this is your E1. Now, your sin I will be equal to, so what is it? Mu1 sin I1, sin I will be equal to mu2 sin R. Smaller angles, so I and R are some small angles for the thinner prisms. So I can write this as mu1 and the R landa podu, and this is your medium. So I can write this I will be equal to mu2 R is the case. So I1 க்கு R1. வெளியே வரும்போது எமர்ஜென்ஸுக்கு, so your I2 will be equal to mu2 R2. That is your emergence will be equal to your mu2 R2 is the case. Correct, sir? So in first refracting surface ku is R1, second refracting surface ku this will be your R2 is the case. So shall I take this as second angle of incidence, small a, b, c, Snell's law which has been applied for AB surface, Snell's law which is applied for the BC surface. What is the deviation formula? General formula D will be equal to I plus E minus A. R1 plus R2 is the case. Now here, I1 plus I2 minus R1 plus R2 is the case. Yes, sir. ஆமா சார். Sorry. You're right. Sorry. Am I right, sir? இங்க mu2 போட்டா sorry. Make it as mu only. Mu. So by adding up it is, I can write it as your deviation will be equal to R1 plus R2 into mu minus 1. And I can also write it as A into mu minus. So this is your expression for your thin prisms. So angle of prism into mu minus 1. Mu is the refractive index of the prism minus 1. என்ன sir? Yes sir. எப்படிடா? B. So second surface la mu2 வந்து 1 so 1 by mu will be equal to sin R2 by sin I2. Incidence இது இல்ல. Correct? So this is going to be your deviation. And whenever the dispersion of light happens, who is the most deviated color? Which is the most deviated color? Violet. Least deviated is red. So when it comes to the dispersion of the light, so if this is the white color, the most deviated, that is and the least deviated. So this will be your red and this is your violet. The most deviated and the least deviated. So இந்த இடத்துல தான் we'll be having it as something called as theta. That is your angular deviation. Angular deviation is nothing but the difference between your most deviated minus the least deviated, which is of deviated of violet minus deviated of your red color. So this is what we call as the angular, the angular dispersion. Correct? So இங்க வந்து உனக்கு இனிஷியலா this will be the value. ரே இப்படி போயிருக்கும். This is your del R and this is your del P. So angular dispersion has been nothing but the difference of your violet, deviation of the violet minus your deviation of the red. Next comes your dispersive power. How much a color is being dispersed? So disperse of color is being given as the ratio of your angular dispersion to your mean dispersion. Okay, va? So in the dispersive power is be denoted as omega. Omega will be equal to இது வந்து angular dispersion. This we all know what del r divided by mean deviation என்ன color? Not exactly the half of it because எல்லா colors over equal angles deviate ஆகாது, right? By the mean deviation, the important color of the deviation here is that it is of yellow. So this yellow is your mean deviation for the spectrum of light, white. So this we call it as the dispersive power. Right? Now, but this I will just end it up. Your del of violet can be written as A into deviation and in terms of angle of refractive index, A into mu minus 1. Correct? Mu of refractive index of what? Red color, sorry, violet color minus 1. So refractive index for over color refractive index keep this in mind. Right? Prism not going to be changing. But for the colors, each has got some refractive indexes. Now similarly for the red color, A into mu r minus. So by applying this in your omega value, which will be equal to mu v minus mu r divided by your mu of yellow minus. This is going to be your dispersive power. Dispersive power on the state board, right? Which is also being carried forward for your JE also. Right, sir? So this is about the thin results. Right? Any doubts here? So from next, in the next physics class, we will just discuss about your, the second half, which is of your optical instruments, is been remaining. And apart from that, in the JE content, we will be just learning it for your Saturday and Sunday. Okay, same link will be shared. You can come offline or the online, right? And more important, like numericals, we will be solving it on. Right, sir. So online students, any doubts?
No, sir.
No, sir.
Sir,
Yes, sir.
sir, will the notes be posted, sir?
Yes, sir. I will post it, sir. I will post it. Right after this class, I will post it in all the 3. Channel, WhatsApp.
Thank you, sir.
Yes, sir. Yes, sir. Yes, sir.
Thank you, sir.
Yes, sir. Huh?
Thank you, sir.
Thank you, sir.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Thank you, sir.
Yes, sir.
Thank you, sir.
Yes, sir. Yes, sir. Hold on.
Thank you, sir.
93 44 69 45 Thank you, sir. Yes, sir. Yeah.